Welcome to Wonderslate. Subscribe to our YouTube channel for more updates. Topic for today's quiz is sound. Question number 1. Our ears are sensitive to a range of frequency. Option A, 20 Hz to 20 kHz. Option B, below 20 Hz. Option C, above 20 kHz. Option D, here is no limit. The correct answer is Option A, 20 Hz to 20 kHz. The human ear can respond to minute pressure variations in the air if they are in the audible frequency range, roughly 20 Hz to 20 kHz. It is capable of detecting pressure variations of less than 1/1000th of atmospheric pressure. Question number 2. The frequency above 20 kHz is called Option A, infrasonic. Option B, ultrasonic. Option C, radio. Option D, none of these. The correct answer is Option B, ultrasonic. All sounds above 20 kHz are qualified as ultrasounds. Human ears cannot detect this sound, but bats can hear this. This type of sound is used for sonar, for underwater observation, in the industry, for quality control testing, in the medical field, for getting knowledge of internal organs using ultrasonography. Question number 3. The sound frequency below 20 Hz is called Option A, infrasonic. Option B, ultrasonic. Option C, radio. Option D, none of these. The correct answer is Option A, infrasonic. Infrasound can be used to send signals in the army to special machines that can pick them up. These can be used to transmit vital data. Animals are able to pick up some low infrasonic noises which warn them of natural disasters, generally earthquakes and tsunamis. Question number 4. Both infrasonic and ultrasonic sounds are inaudible to human beings. Option A, true. Option B, false. The correct answer is Option A, true. The audible range of human beings is 20 Hz to 20 kHz. Question number 5. The maximum displacement of the particle of a medium on either side of its mean position is called Option A, amplitude. Option B, frequency. Option C, time period. Option D, wavelength. The correct answer is Option A, amplitude. Amplitude, in physics, the maximum displacement or distance moved by a point on a vibrating body or wave measured from its equilibrium position. It is equal to 1/2 of the length of the vibration path. Question number 6. The time taken by a particle of medium to complete its one vibration is called Option A, amplitude. Option B, frequency. Option C, time period. Option D, wavelength. The correct answer is Option C, time period. A time period, denoted by T, is the time taken for one complete cycle of vibration to pass a given point. As the frequency of a wave increases, the time period of the wave decreases. The unit for the time period is seconds. Question number 7. The number of vibration made by the particle of the medium in 1 second is called Option A, amplitude. Option B, frequency. Option C, time period. Option D, wavelength. The correct answer is Option B, frequency. Frequency describes the number of waves that pass a fixed place in a given amount of time. So if the time it takes for a wave to pass is half a second, the frequency is 2 per second. If it takes 1/100th of an hour, the frequency is 100 per hour. Question number 8. Is the frequency of a sound wave depends on the medium? Option A, yes. Option B, no. The correct answer is Option B, no. Frequency is dependent only on the source. From a fixed vibrating body, frequency remains always the same. Question number 9. During the propagation of the sound wave in the medium through medium particle, then which energy converts to which energy? Option A, kinetic energy to potential energy. Option B. Potential energy to kinetic energy. Option C. Both A and B happen simultaneously. Option D. None of these. The correct answer is option C. Both A and B happen simultaneously. When medium particles vibrate, then kinetic energy changes to potential energy and vice versa. For this reason, the sound wave is called a mechanical or elastic wave. Question number 10. When the vibration of medium particles are along the direction of propagation of the sound wave is called option A. Longitudinal wave. Option B. Transverse wave. Option C. Both longitudinal waves and transverse wave. Option D. None of these. The correct answer is option A. Longitudinal wave. Sound waves in liquid, air, gas are longitudinal type wave. Question number 11. When the vibration of medium particles are along the perpendicular direction of propagation of the sound wave is called option A. Longitudinal wave. Option B. Transverse wave. Option C. Both longitudinal waves and transverse wave. Option D. None of these. The correct answer is option B. Transverse wave. Sound wave on the surface of a liquid is a transverse wave. Question number 12. Which type of waves consists of crests and throws? Option A. Longitudinal wave. Option B. Transverse wave. Option C. Both longitudinal waves and transverse wave. Option D. None of these. The correct answer is option B. Transverse wave. A transverse wave consists of crests and troughs. The elevation or hump in a transverse wave is called the crest. It is that part of the transverse wave in which all the medium particles are above the line of zero disturbance of the medium. Question number 13. The average amount of energy passing through a unit area per unit time in a specified direction is called underscore of the wave. Option A. Loudness. Option B. Intensity. Option C. Pitch. Option D. Quality. The correct answer is option B. Intensity. The intensity of the wave is defined as the average amount of energy passing through a unit area per unit time in a specified direction. Question number 14. The kind of motion in which transfer of energy takes place when the particles move about their mean position is called underscore motion. Option A. Oscillatory. Option B. Rotational. Option C. Vibrational. Option D. Wave. The correct answer is option D. Wave. When a disturbance is created in an elastic medium, it is transferred from one particle to another particle in the form of a wave. This type of propagation is known as wave motion. Question number 15. Which of the following devices does not work on the principle of multiple reflections of sound? Option A. Gramophone. Option B. Megaphone. Option C. Stethoscope. Option D. Bulb horn. The correct answer is option A. Gramophone. Gramophone does not work on the principle of multiple reflection of sound. Devices like a megaphone, bulb horn, stethoscope, and soundboards work on the principle of multiple reflection of sound. Question number 16. Which of the following is not an example of free vibrations? Option A. If the bob of a simple pendulum is disturbed, it oscillates about its mean position. Option B. A load suspended from a spring when compressed and released oscillates about its mean position. Option C. A stretched string when plucked at its midpoint executes oscillations. Option D. Vibrations of the diaphragm in a radio speaker. The correct answer is option D. Vibrations of the diaphragm in a radio speaker. Vibrations of the diaphragm in a radio speaker are according to the frequencies fed to it and are not natural. They have forced vibrations. Question number 17. The characteristic of a sound which distinguishes a feeble sound from a loud sound of the same frequency is called underscore. Option A. Loudness. Option B. Music. Option C. Pitch. Option D. Noise. The correct answer is Option A. Loudness. The characteristic of a sound which distinguishes a feeble sound from a loud sound of the same frequency is called loudness. Question number 18. A wire stretched between two fixed supports is plucked exactly in the middle and then released. It executes. Option A. Resonant vibrations. Option B. Natural vibrations. Option C. Damped vibrations. Option D. Forced vibrations. The correct answer is Option B. Natural vibrations. The periodic vibrations of a body of constant amplitude in the absence of any external force on it are called natural vibrations. Question number 19. When a body vibrates under a periodic force, the vibrations of the body are Option A. Natural vibrations. Option B. Damped vibrations. Option C. Forced vibration. Option D. Resonant vibrations. The correct answer is Option C. Forced vibration. The vibrations of a body which take place under the influence of external periodic force acting on it are called the forced vibrations. Question number 20. A tuning fork of frequency 256 Hz will resonate with another tuning fork of frequency. Option A. 28 Hz. Option B. 256 Hz. Option C. 384 Hz. Option D. 512 Hz. The correct answer is Option C. 384 Hz. A tuning fork of frequency 256 Hz will resonate with another tuning fork of frequency 256 Hz. Resonance occurs when the frequency of an externally applied periodic force on the body is equal to its natural frequency. Thank you for watching the video. If you'd like practice this quiz, then download the Wonderslate app now. Link in the description below. If you have any suggestion for us, feel free to leave comments. If you liked the video and want to see more of it, hit the thumbs up and don't forget to click on subscribe button to get more updates of the future videos.